Hello students, how are you doing today? Let's just get straight into the business, shall we? No need to talk about what happened yesterday in Michigan's basketball game. I think you all know. Anyway, so last lesson we learned about sigma notation, taking a sequence of numbers, converting it into a series using sigma notation, and then adding them all up together. Well, as you can see in my first example today, what if they want you to add 30 numbers together? 8 plus 11 plus 14 plus 17 plus 20 plus blah, 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 until there are 30 numbers listed, and they want you to add up all 30 of those numbers. Well, as I will show in class on Monday, as I'll show in class on Monday, you could use this handy-dandy formula to tell you what this series adds up to. Essentially, when you think about it, a1 plus an, the first plus the last term, added together divided by 2. So you're taking the average of the first and the last terms and then multiplying it by the number of terms in the series. And we'll talk about that, where that formula comes from, on Monday. But just for this lesson, you just need to know that this is exactly true. Now, there are different forms, like algebraically equivalent forms of this equation that people like to use. You essentially have n divided by 2, so you could think of this as n divided by 2 times a1 plus an. Some people like to think about it that way. Some people like to think about it as you could distribute this and put it all into a fraction, so it would be like n. I guess you're not distributing it, but you're just going n times the numerator, a1 plus an, and then whatever that works out to be, divide everything by 2. Anyway, if one of these three equations sounds better to you than the others, you should use that one. I don't know which one I prefer. I don't think I'd prefer that one. I think I would like to use this one or that one. One of those two. Anyway, let's do this problem here. I want to figure out what all of these add up to, but the problem is that I don't know what an is. I don't know what this 30th number is, so enter this equation here. This equation helps you find any number in your series. So in this case, I want to know what A30 is. You could call this U30 if you want, because they're using a U here. A's and U's, same thing. D, that's kind of, this is, if you notice, this is just like point slope form. With the slope, the n minus 1 for the first term, and the first term is A1. Anyway, the slope, we're adding 3 to get from number to number to number. And then I just changed the n to 30. So 30 minus 1 plus a1, so plus 8. Let's see, 30 minus 1, that's 29. 3 times 29 plus 8. 3 times 29, 87. And 87 plus 8 is 95. So I know that A30 is 95, so now I can go ahead and work out S30. S30, the sum of these first 30 terms, is A1 plus AN, so A1 is 8, plus AN, that was U30, which is 95. That divided by 2 times the number of numbers in the series, which are 30 of them, and work it all out. So S30 is 8, let's see, that's 105, and 30 divided by 2, that's 15, and 105, okay, 105 times 15, I'm going to have to cheat and use a calculator here. These are calculator problems, but you shouldn't need super fancy calculators here. 105 times 15, I have 1,575. All right. Second example today. Same type thing. 3 plus 9 plus 15 plus 21 plus ... plus 123. So I have A1 and I have an, the last term, 123, but I also need to know how many numbers are in the series, and because of going this dot, 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 I don't know precisely how many numbers there are in this series. So I'm going to use this equation and algebraically figure out the number of terms in the series. So an, that's the final term in the series, that's 123. 123 equals that slope, we're adding 6 times, I'm looking for n, so n minus 1 plus a1, 3. All right, algebra. Subtract 3 from both sides. 120 equals 6 times n minus 1. Divide both sides by 6, so 20 equals n minus 1. That means n equals 21. And now that I know that n equals 21, I can go ahead and figure out what this sum adds up to. There are 21 terms here, from here to here, so this is S21 equals the first term plus the last term, 3 plus 1, start over, 3 plus 123, that all divided by 2, times the number of terms in the sequence, which are 21. 3 plus 123, that works out to be 126. 126 divided by 2 is 63. And 63 times 21, 1,323. Put a comma there. Nice. So that is what that series adds up to. All right, just one more example for you today. Example number 3. On this one, they actually give me the sigma notation. Elliot's going to get a piece of white paper. I'm back. Hello. So number 3, sigma. Well, that's a nice looking sigma. It's not perfect though, it could be a lot better. K equals 1. You don't have to use n, sometimes they use k. K equals 1 to 38 of 3k plus 10. Sometimes I like to use n's on these problems, but as you can see, this problem's using a k. Sigma. So I know that I'm adding up the terms, and here I see a slope 3 times k. That means this is going to be a linear equation or an arithmetic series. So I use the arithmetic series formulas. On test day, you're going to have to be able to look at this and determine, just by looking at this equation, or by adding in putting in a couple terms, whether it's arithmetic or geometric. And in this case, there's a slope, so it's arithmetic. So Sn, it says 1 to 38, so I know that I'm doing S38 equals A1 plus AN, or A38. So I have to figure those out. A1, that's 3 times 1 plus 10, which is 13. And then I need to know A38 as well, the last number to plug into this series. So that's 3 times 38 plus 10. 3 times 38, 90, plus 24. 114 plus 10, 124. Elliot's going to double check. 3 times 38, 114 plus 10, 124. Yep. So I have 13 plus 124 divided by 2, and then times the number of terms in the sequence, which is 38. And these add up to an odd number of 137. So I'm going to kind of shift this to, I don't want to divide by 2 and have that become a decimal, 0.5. So I'm just going to kind of shift this divide by 2 over to here. And you can do that because it's all held together by multiplication and division. So 38 divided by 2 is 19. And then 137 times 19 is 2,603. So that was using taking a sigma notation and figuring out what those 38 terms would add up to. So those are some nice shortcuts using arithmetic series. And that's all I have to show you for today. So I hope you had yourselves a wonderful weekend. And now it's time to roll up our sleeves and do some arithmetic series worksheet. Have a great day. Here, let me give you a quick look at arithmetic series worksheet. Why not? Ooh, it involves some book problems. Book, page 521. So you might want to bring page 521, take a picture of page 521. That is horribly out of focus. Oh, I'll just put it down here. There it is. Arithmetic series worksheet. You could take a screenshot of it, I guess. Or you could also just look and find it on the website. Either way, Elliot out. Have a great day. Bye-bye.